Look at this ultra-soft, breathable green hoodie sitting in front of you. What if I told you that less than 72 hours ago, this luxurious fabric was a razor-sharp, rock-hard stalk of wild bamboo growing on a misty mountain slope? Right now, you are wearing clothes made from wood, but almost nobody realizes the terrifying engineering force required to turn a plant tough enough to build scaffolding into a shirt softer than Egyptian cotton. Think about this. How do you take a green stem that can snap a steel blade and liquefy it into microscopic threads without destroying the planet in the process? What happens next inside this high-tech facility surprised even the most experienced textile engineers, and it changes everything you thought you knew about the clothes on your back. Imagine standing at the base of a roaring industrial furnace, watching thousands of pounds of raw green timber get pulverized into powder in a fraction of a second. Most people never think about where their eco-friendly activewear actually comes from, assuming it is gently harvested by hand in small backyards. But here's what nobody tells you. To meet global demand for sustainable fashion, modern manufacturing operates at a scale that feels almost terrifying. Every single minute, giant industrial chippers swallow whole trees, converting raw organic matter into liquid silk using extreme heat, massive pressure, and cutting-edge mechanical power. We are about to go deep inside one of the most secretive, advanced fabric mills on Earth to witness the complete, step-by-step transformation of wild bamboo into high-performance t-shirts, heavy-duty hoodies, and tailored trousers. Before a single thread can be woven, we have to travel directly to the source where this incredible journey begins. High in the humid bamboo reserves of Sichuan Province, China, giant Moso bamboo grows at a staggering rate of up to 91 centimeters in a single 24-hour period. Because bamboo is technically a fast-growing grass rather than a tree, it requires zero synthetic pesticides, zero artificial fertilizers, and consumes up to 8 times less water than conventional cotton crops. But harvesting this natural monster is a brutal, dangerous job that requires precision timing and massive logistical coordination. If the bamboo is cut too young, the fibers are too weak. If it is harvested too old, the rigid lignin content becomes almost impossible to break down inside the factory digesters. Teams of specialized forestry workers navigate the steep, slippery slopes armed with heavy-duty hydraulic cutters and tungsten carbide saws. They target stalks that are precisely 3 to 5 years old, reaching towering heights of 20 meters and diameters exceeding 15 centimeters. Each mature stalk weighs over 40 kilograms, and forestry crews harvest thousands of metric tons per day with surgical speed. Once felled, the massive bamboo poles are stripped of their branches, bundled into 2-ton loads, and hoisted onto overhead steel zip lines that span deep mountain ravines. These heavy bundles travel over 1,200 kilometers by specialized freight transport directly to the primary refining facility, maintaining strict moisture monitoring throughout the entire transit to prevent premature fungal degradation. When the raw bamboo arrives at the primary refining facility, the sheer volume of material is overwhelming. It takes roughly 3 metric tons of raw green bamboo to yield just 1 single ton of finished high-purity bamboo pulp. The market price for raw bamboo timber floats around $450 to $600 per metric ton, making raw material selection a multi-million-dollar calculation for global mills. Here, massive crane arms unload the long green trunks onto continuous conveyor systems operating 24 hours a day. The material undergoes a critical chemical purity test, verifying that the natural cellulose concentration sits comfortably above 46% before entering the shredding floor. But here is a supply chain secret most people never know. If the moisture content varies by even 3% across a batch, the downstream chemical digestion will fail completely, ruining hundreds of thousands of dollars of raw material in seconds. From an environmental standpoint, this raw stage is where bamboo proves its massive ecological power compared to petroleum-based synthetics or water-hungry cotton. A mature bamboo grove sequesters up to 35% more carbon dioxide than an equivalent stand of hardwood trees, while producing 30% more atmospheric oxygen. However, turning this hard, eco-friendly timber into a soft, wearable garment requires unlocking the cellular walls of the plant itself. The raw bamboo stalks are driven straight into heavy industrial chippers, equipped with 6 rotating carbide blades spinning at 900 RPM. In a fraction of a second, the solid timber is sliced into precise, uniform chips measuring exactly 20 millimeters long by 5 millimeters thick. But as these fresh chips pour out of the chipper in a massive green waterfall, they face a high-pressure baptism that will completely alter their molecular structure. Now the raw chips are launched into the heart of the chemical digestion floor, where the real magic and extreme danger begins. The chips are dumped into massive, stainless steel pressure digesters that stand over 4 stories tall. Here, the raw wood chips are bathed in a mild alkaline solution of sodium hydroxide and carbon disulfide, sealed airtight, and blasted with superheated steam. The temperature inside these pressure cookers skyrockets to precisely 170 degrees Celsius, or 338 degrees Fahrenheit, under a crushing pressure of 7.5 bar. For 6 uninterrupted hours, this extreme environment breaks down the rigid organic lignin, the natural glue holding the bamboo plant together, leaving behind a pure, golden-brown slurry of raw bamboo cellulose pulp. When the digester valves release, thousands of gallons of superheated cellulose pulp shoot through heavy industrial pipes, filling the facility with a deep, earthy, cooked grain aroma. The raw pulp is pumped into multi-stage rotary vacuum washers, where over 99% of the processing chemicals are recovered, neutralized, and recycled back into the system in a closed loop. The washed pulp is then treated with eco-friendly hydrogen peroxide bleaching agents, transforming the brown slurry into a blindingly white, sheet-like material. These sheets are pressed dry under 20-ton hydraulic rollers, coming out as thick sheets of pure bamboo pulp paper that look like heavy cardboard. But how do you take a stiff, cardboard-like sheet of wood pulp and turn it into a silky, flowing thread fine enough to stitch a premium t-shirt? And this is where the solid white pulp sheets are transported into the viscose dissolving building, where they are torn apart by high-speed mechanical shredders into fluffy white crumbs known as white crumb. These crumbs are fed into temperature-controlled aging chambers maintained at a strict 28 degrees Celsius, or 82.4 degrees Fahrenheit, for 18 hours to allow controlled molecular depolymerization. Next, the aged crumb is mixed with dilute sodium hydroxide inside massive high-shear mixers to form a golden yellow, viscous fluid known in the industry as spinning dope. This liquid has the exact consistency and color of warm golden honey, with a viscosity measured precisely at 45 poise. Every single bubble and microscopic impurity must be vacuum extracted from this honey-like fluid over 12 hours. A single trapped air bubble would cause a catastrophic thread break during the extrusion phase. Now comes the ultimate physical transformation, wet spinning. The golden bamboo dope is pressurized at 12 bar and forced through platinum gold alloy spinneret nozzles submerged in an acid coagulation bath. Each spinneret head is no larger than a silver coin, yet contains up to 40,000 microscopic holes, each measuring a tiny 50 microns in diameter, thinner than a human hair. The spin bath contains a precise chemical formula: 10% sulfuric acid, 20% sodium sulfate, and 1.5% zinc sulfate, maintained at 48 degrees Celsius or 118.4 degrees Fahrenheit. The instant the liquid bamboo dope squirts out of the microscopic nozzle holes into the acid bath, a chemical reaction solidifies the liquid stream back into pure, solid continuous cellulose filaments at a blistering speed of 80 meters per minute. As thousands of microscopic continuous threads emerge in the liquid bath, they are instantly gathered by Godet rollers spinning at high speeds. These heavy rollers stretch the freshly formed fibers by up to 120% while under tension. Stretching aligns the internal cellulose polymer chains along the axis of the fiber, boosting the tensile strength from a fragile strand to a tough, durable textile fiber capable of withstanding extreme wear and tear. The continuous shiny filaments pass through a multi-stage hot water washing line operating at 90 degrees Celsius to scrub away all residual acid salts. Then, high-speed rotary toe cutters slice the continuous filaments into precise 38mm staple fibers, mimicking the exact length of long staple natural cotton. The wet staple fibers enter colossal steam-heated rotary drum dryers operating at a scorching 110 degrees Celsius, or 230 degrees Fahrenheit. As the moisture evaporates, the dense clump of wet fibers expands into an explosion of blinding white, insanely soft, cloud-like fleece. Workers grab handfuls of this freshly dried raw bamboo fiber, and the feeling is shocking. It is lighter than wool, cooler than cotton, and as soft as pure cashmere. These fluffy white clouds are vacuum blown through large overhead pneumatic tubes directly into the automated spinning mill at a rate of 2 tons per hour. What happens next inside the spinning mill surprised even experienced engineers, because taking this ultra-soft cloud and twisting it into high-strength yarn requires taming static electricity that can ruin entire production runs in milliseconds. Inside the spinning plant, the raw bamboo fiber cloud enters massive carding machines. Thousands of wire teeth spinning on heavy steel drums comb the tangled fiber mass, stripping away short unviable fragments and aligning every individual fiber into a perfectly parallel web. This web is gathered into a rope-like strand called a sliver. The slivers are fed into high-speed air-jet spinning frames operating at an astonishing 400 meters per minute with spindle speeds hitting 15,000 RPM. Compressed air swirls around a fiber core at vortex speeds, twisting the loose bamboo strands into ultra-uniform, high-tenacity bamboo yarn. This yarn possesses a natural antibacterial property known as bamboo cooin, which prevents odor-causing bacteria from growing on the fiber, even after dozens of high-temperature wash cycles. With millions of meters of pure bamboo yarn wound onto heavy plastic bobbins, the material branches off into 2 distinct textile pathways: knitting for light t-shirts and heavy hoodies, and high-density weaving for durable trousers. For t-shirts and hoodies, the bobbins are loaded onto high-speed circular knitting machines equipped with over 2,800 precision latch needles. Operating at 30 revolutions per minute, these circular giants knit seamless tubular jersey in heavy French terry fleece fabric at a speed of 60 linear meters per hour. The sound inside this room is a deafening, rhythmically hypnotic metallic roar as thousands of needles dance up and down in microsecond synchronicity. For the structured bamboo trousers, the yarn takes a totally different route onto high-speed air-jet weaving looms. These engineering marvels shoot a pick thread across a 2-meter-wide warp sheet, using a pulse of high-pressure air at speeds exceeding 1,200 picks per minute. So fast a human eye cannot even track the moving yarn. Once the raw gray fabric webs emerge from the looms and knitting machines, they are fed into automated closed-loop jet dyeing vats. The fabric is saturated with non-toxic, eco-friendly reactive dyes at 60 degrees Celsius for 90 minutes under high pressure, permanently bonding vibrant colors deep inside the bamboo fiber structures, while recycling 98% of the water used in the process. Every single millimeter of dyed bamboo fabric moving through this factory is subjected to hyper-advanced artificial intelligence quality control systems before it ever touches a cutting table. High-speed optical scanners powered by 4K line-skin camera arrays scan the fabric moving at 100 meters per minute under calibrated ultraviolet and infrared lighting. These AI vision systems can spot structural weave defects, oil spots, thread thickness deviations, and color shade shifts as small as 0.1 millimeters in real time. The system automatically tags the exact coordinates of any flaw, dropping factory defect rates down from 5% to a world-class 1.2%. Any section failing inspection is automatically routed. Once cleared by AI vision, rolls of green fabric move into automated laser cutting suites for garment pattern production. Massive CNC laser cutting beds slice through 30 layers of stacked bamboo fabric simultaneously with micron-level precision, guided by digital CAD patterns that optimize yield down to 94% fabric utilization. For hoodies and t-shirts, laser-cut panels are stitched together by skilled operators using 4-thread overlock seamers running at 7,000 stitches per minute. For the trousers, heavy-duty double-needle lock-stitch machines insert reinforced seams designed to withstand over 800 newtons of tearing force. But even with the most advanced automation on Earth, there's one critical quality test where machine algorithms fall short and human mastery takes complete control. Before any finished batch of bamboo apparel receives final shipping clearance, human-mastered textile dyers perform color consistency matching inside specialized spectral light chambers. Machines can measure wavelength reflections, but only the trained human eye can detect subtle metamerism, how a garment's shade changes when moving from warm indoor tungsten lights to harsh, natural outdoor daylight. Master dyers evaluate samples under standardized D65 daylight simulators, ensuring that a pair of bamboo trousers matches a bamboo hoodie down to the exact visual hue under any lighting condition on Earth. Furthermore, samples from every batch undergo rigorous Martindale abrasion testing, where mechanical pads rub the fabric under 9 kilopascals of pressure for 50,000 continuous cycles to guarantee zero pilling or surface, were over years of heavy use. This rigorous testing ensures compliance with the most stringent global standards, including OEKOTX Standard 100 Class 1 certification, proving the finished garments contain zero harmful chemical residues and are safe for sensitive skin. Closed-loop lyocell processing facilities even achieve a 99.7% solvent recovery rate, earning international EU Ecolabel certification. In bursting strength tests, bamboo hoodie fleece endures over 400 kilopascals of hydraulic pressure before rupturing, proving that sustainable plant-based fabrics can outlast traditional synthetic polyesters. But how big is this global sustainable revolution, and what do the staggering numbers behind the worldwide bamboo textile industry actually look like? When you look at the macro scale, the global bamboo fabric and viscose market is exploding at an unprecedented rate, projected to reach a staggering $14.8 billion globally by the end of 2026. Worldwide, factories produce over 6.5 million metric tons of regenerated cellulosic fibers every year, with bamboo-based textiles representing the fastest-growing segment of that volume. China currently dominates global output, producing roughly 62% of the world's bamboo fiber, followed by India at 14%, Indonesia at 9%, Austria at 5%, and Brazil at 4%. More than 2.3 million workers are directly employed across the global bamboo harvesting and textile manufacturing supply chain, turning a wild mountain grass into a dominant engine of international commerce. To put these production numbers into perspective, the total amount of bamboo yarn spun every single year could wrap around the entire Earth over 180,000 times. 50 years ago, bamboo was considered nothing more than a cheap building material or local fuel source, completely useless for fine garment manufacturing due to its rough, woody fiber structure. The invention of eco-friendly closed-loop chemical dissolution and high-speed wet spinning completely revolutionized the textile industry, paving the way for zero-waste production facilities over the next decade. And here are 3 shocking facts you probably never knew. First, bamboo grows so fast to hold the Guinness World Record as the fastest-growing plant on Earth, capable of growing nearly 4 centimeters in a single hour. Second, bamboo fabric naturally blocks up to 98% of harmful UV rays. And third, a single acre of bamboo yields up to 10 times more usable fiber than an acre of conventional cotton, without using a single drop of artificial irrigation. From wild, unyielding mountain stalks to precision chemical digestion, high-speed wet spinning, AI quality control, and luxury garment construction, we have witnessed a complete, mind-blowing transformation of bamboo into high-performance fashion. What started as hard green timber on a foggy hillside have been completely re-engineered into soft, durable, ultra-sustainable t-shirts, hoodies, and trousers worn by millions of people across the globe. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.